Hi guys, today I'm going to talk about how you can calibrate a rain gauge. This is specifically a Rainwise that I'm using in my weather projects. I have 4 of these units and they work excellent, but sometimes you need to calibrate them because they're either showing too little or too high values. And this video is about how you know what is enough and how many tips you should have for the rain amount that is falling down. It's a pretty simple construction here. It's very sturdy and solid construction, and it's easy to extend also. So either you can put your sensor or radio equipment down in this container with a lid on it, or you can have it semi-wired out to some external where you maybe have some central place where you have an anemometer on temperature, etc. that I have in some of my products also. It's good to have it only works well if you have it in level. So I put a simple level here, but otherwise you should measure really with when you have the thing in place, you really need to make it stay in level, or you will get false readings also. It's a really simple construction, these rain gauges. It's a reed switch that as soon as you it comes close to this magnet, it closes like a switch, and then as soon as it passes it, it releases again. So you can almost hear a tick when you pass it here. There's a small tick, tick, and so that's how it works. And then you use the microprocessor to calculate that. Included in this hardware, you get a pulse counter so that you can zero. And this is good when you're going to calibrate it. So if you just want to calculate how many tips you have per for a certain amount of water. And that's what I'm going to show right now. So how do we know how much it should be? Well, first of all, we need to measure the tipping bucket here. And this one is 205 millimeters in the diameter. And then if we do some simple math, that sums up then to certain amount of square millimeters, and if you translate that into how much volume that would be for 1 millimeter, that is then 3.3 centiliters for every millimeter that is falling. So then we have established the volume, how much the area that we're covering in this bucket. And if you try to do this for a rain gauge that has a very strange looking shape, I would say that is mainly because it's not a very exact rain gauge, and it will be really hard for you to calculate the exact size of it. That's probably because it's a quite poor rain gauge also. But one good way to do this is to take a normal bottle of PT. It could be any size. You just have to establish what that exact volume is. And to do this, you also need to have, there's going to be, I've drilled a small hole in the bottom here of it. It's 2.5 millimeters. So it's going to drip out the water at a certain pace. And to be able to determine how fast it should drip this one, I mean, if you just drill this hole and fill this bottle, it will go too fast, at least in the end. And in the beginning, when it's really full, it's going to be a bit slower also. So to be able to compensate for this, I've taken a small hose here. This is from a Gardena micro drip system. So the point here is that I've added this valve here so I can control the airflow. So what it basically does is when you add this down to the bottle, and when it's full of water, then it's going to be able to control how much air. So you will see bubbles going up here, so you can control the pace, and you can actually see a good rate is typically 1 bubble per second, in my case at least. Typically what you want to do is to get you shouldn't be able to empty this bottle faster than maybe 20 minutes. So 20 minutes, half an hour, that is a quite optimal rate, because as you can imagine, if it goes really fast and you have tips going like crazy here, you will lose quite a lot of pulses here, because it's just gonna pour water everywhere if it's going too fast. There are some protection for that in the funnel of the hardware here, but it still is not enough. So I mean, it goes too fast, you will lose pulses here, and just water going on places it's not really designed for. Yeah. So, and how do you establish the volume in this one? Especially now, if you add this hose in here, that's going to take a few centiliters. So in my case, when I fill this up completely and I have screwed it tightly here, so then it's completely full. You should do this before you drill this hole, because otherwise it would seep out. So you just measure then the actual how much it weighs, the total volume here. You can exclude the hose here, it doesn't really matter. So you know how much is in here, and then you measure how much the actual bottle is weighing, so you can subtract that, and then you will get the volume. I mean, one milliliter is equals 1 gram, so it's simple enough to calculate on. And when you then, so if in this case I had a bottle here of 103 centiliters, and if we then say that it took 3.3 centiliters for every millimeter, then that becomes, when we have emptied this bottle, that should sum up to 31.22 millimeters. And if we translate this into ticks, that is then one tip is 0.25 millimeters. So that would, those 31 millimeters of fluid, that would be 123 tips then. And as you can see in this case, it was 133. So as I mentioned before, to solve that problem, then you need to screw these screws a bit further down. I mean, we want to be able to tip it for a longer time before it tips over to the other side, and you do that on the on both screws here, on both ends, so you have a even flow. And yeah, I mean, that's basically it, and take just a small step at a time. And then it works really well. So I've often have to tune in this, like in this case, 133 down to 123. That's typically maybe just one rotation with a screwdriver or something like that. So it's you take it careful and step by step. And for every such adjustments, it's basically fill up a new bottle and let it stand there for half an hour. Because if you do it too fast, you will just get bogus values. I mean, sometimes it's going to show 110, sometimes it's going to show 130, so it's going to be a huge variation here if you don't do it properly. So very important here to get this to have some kind of even flow of the air here. But yeah, that's how you can calibrate your rain gauge. Thank you very much for listening. Bye.